job is to remind you, your job is to follow, so I can only be conscious. If you are doing real numbers, very good. If you have still not started real numbers, you're slightly behind. If you don't start by today also, because next class I won't do real numbers. By next class, I'm going to ask you only, did you have any doubt? And if you had doubt, very good. If you didn't have doubt, yeah, bolo beta. Root 5 minus
root 3. So like I wrote it as root 5 minus root 3 by 1, and then I wrote root 5 minus root 3.
Actually, it's that number, that problem will not come in. Those are grade 10 type problems. Root 5 minus root 3, आपको prove that irrational you need not do at all. You need not do at all. That is not in your syllabus. That is a grade 10 problem. Prove that a number is irrational is not there. If it comes at your level, the way you are supposed to prove it is root 5 is irrational, root 3 is irrational, and the difference of two unequal irrational numbers is always irrational. Please understand, if it was root 2 minus root 2, then irrational minus irrational gives you 0, which is rational. Unless and until the two irrational numbers are equal, their difference can never be rational. So at your grade, you just write this much. उससे ज़्यादा आपको नहीं चाहिए. You don't have proof in your syllabus. ठीक है? Okay. So again, since this we are starting with our revision classes, so I won't be able to go that deep into the chapter, but I will be able to cover every topic. So while the name of the topic will always be motion, we will say that this is motion in a straight line. नहीं, ऐसे भी नहीं बोलेंगे. We'll say, we will always say that this chapter is all about uniformly accelerated motion, okay, in a straight line. That means in this chapter, whatever questions we are going to get, our questions are always going to be of the order that the body follows a motion path which is a straight line. हमारा जो body होगा वो straight line motion में ही जाएगा इस पूरे chapter में. This body is going to follow a straight line path. That means for us to understand, everything that the body covers will be nothing but displacement. है ना? Even if question says distance. Now we are supposed to see fine points of our chapter. Even if question says distance, everything will be displacement. Then the next part says that, okay, ये कहाँ से हमें पता चला? This we got to know from this part. This is straight line. Number one, वहाँ से हमने ये decode किया. Number two, it says uniformly accelerated. This is 2. That means in this chapter, whatever motion we are going to get, we are going to have motions which will have uniform acceleration. Uniform acceleration or no acceleration. No acceleration का case तो भाई साहब rare होगा. This is grade 6 type problem. So you'll have uniform acceleration, means whatever acceleration we have, that acceleration will be constant throughout the problem. Throughout the problem. You need not bother about it. That acceleration will be constant throughout the problem. So this is our number 2. These are very important things that I'm writing even for your grade 11. Grade 11 में जाके फटाक से question, you will apply this equations कहाँ apply करना है कहाँ नहीं करना है आपको यहीं से पता चलेगा. So uniform acceleration or no acceleration, and acceleration will be constant throughout the system. And then another thing that we get from here is that since there is acceleration, that means velocity has to change. Velocity has to change. The question is, velocity has to change, since acceleration is always change in velocity over change of time. Okay, acceleration is delta v upon delta t. Delta v is change in velocity and delta t is change in time. Velocity has to change. Now in our question we will say that velocity being a vector, it will have two different parameters. One is the mag and one is direction. One is mag and one is direction. So any change any change in magnitude or any change in direction. Any change in magnitude or any change, okay, either of these. So I say any change, इन दोनों में से any change leads to डेल्टा वी, एनी चेंज लीड्स टू डेल्टा वी. बट यू ऑल आर किडोस, छोटे छोटे बच्चे हैं, आप ज्यादातर इस चेंज को ही देखेंगे ग्रेड 9 में. तो 9th grade you will see change in the magnitude. However, if you go back to chemistry, we saw this change also. Electrons in Rutherford model में electrons move in circular orbit. In circular orbit, velocity is same, but the direction of velocity is changing. That's why we used to say electrons are having accelerated motion. ये चेंज होने से भी एक्सेलरेशन होगा. ये चेंज ग्रेड 11 में ये तो बहुत जगह चेंज होगा आपका. आपको प्रॉब्लम देख के समझ में आना पड़ेगा कि प्रॉब्लम में एक्सेलरेशन है कि नहीं. सपोज फॉर एग्जांपल a DVD डिस्क, राइट? हाउ डज अ DVD डिस्क लुक लाइक? जरा देखो तो DVD डिस्क कैसा दिखता है हमें. हमारा DVD डिस्क कुछ ऐसा दिखता है. दिस इज अ DVD डिस्क. ओके, नाउ लेट्स टेक वन पॉइंट ऑन दिस DVD डिस्क. लेट्स टेक से वन पॉइंट. यहाँ पे एक पॉइंट लो. ये पॉइंट का वेलोसिटी इधर रहेगा, ये पॉइंट इधर है. एज द डिस्क इज रोटेटिंग, and the disk is rotating at what? We will say the disk is rotating at 3000 rpm, means 3000 revolutions per minute. Constant velocity में घूम रहा है. Drill machine 2200 rpm. गाड़ी, your engine, have you seen your car? The car will always have in the speedometer two dials. One is the odometer and one is the tachometer. The tachometer shows you engine rpm. As soon as you press the accelerator, boom, it will just go up. So usually we drive a 4-stroke car at how much? 2200 rpm. 2200 rpm means engine is rotating at 2200 revolutions. So मान लो ये engine का shaft है. It's rotating at how much? 2200 rpm. But this point has a different velocity. This point has a different velocity. Not by magnitude, but by direction. Grade 9 में ये आपको लोग इतना तंग नहीं करेंगे. But when you go to grade 11, keep this thing open. यार 9 में तो मैंने magnitude के problem किए थे. अब मैं senior हो गया हूँ. अब मैं direction के problem. This will come in chapters of angular motion. You will get something. Now you're learning only translational motion. आप सिर्फ velocity पढ़ते हैं. आप तब जाके angular velocity पढ़ेंगे. Linear acceleration, angular acceleration, centripetal acceleration, tangential acceleration. Acceleration के 3 भाई आएंगे. What you are now reading is only the easy part of the tangential or linear acceleration जिसको हम बोलते हैं. ठीक है? तो any change in velocity will any of this change. तो 9th grade में हमें क्या ध्यान रखना है? Magnitude change होगा. चलो मैपिंग कर करके पढ़ते हैं, बढ़िया लगेगा. मैग्नीट्यूड चेंज होने से हमारे पास एक इनिशियल वेलोसिटी आता है प्रॉब्लम में, एक फाइनल वेलोसिटी आता है ना. दिस इज कॉल्ड इनिशियल वेलोसिटी एंड दिस इज कॉल्ड फाइनल वेलोसिटी. ठीक है, वन इज इनिशियल एंड वन इज अ फाइनल. सो वी गो बैक टू आवर फॉर्मूला एंड वी से दैट द डेल्टा v that we were saying will always be the v final. Always difference is final minus initial in physics. Whether it is less or more, that's not your headache. तो इसको कैसे लिखते हैं? V minus U, right? And say delta t is equal to t. Okay, that means my acceleration becomes equals to V minus U by t. Now, since velocity is vector, हमने लिखा था ना, since velocity is vector, अगर बाप vector है तो automatically बेटा भी vector ही होगा. Now question arises. If this body has an initial velocity u and after some time, देखिए कुछ समय के बाद ये बॉडी यहां पहुंच जाता है. ठीक है, कुछ समय के बाद this body goes here and the velocity is v and the time elapsed is t, then we say that the body is undergoing an acceleration which is equal to v minus u by t. Now since acceleration is a vector, our question again arises, भाई साहब इस एक्सेलरेशन का डायरेक्शन क्या है? सो वी विल से व्हाटएवर इज द डायरेक्शन ऑफ v, जो v का डायरेक्शन होगा वही एक्सेलरेशन का डायरेक्शन होगा. रिमेंबर दैट. सेम थिंग वी विल यूज इन नेक्स्ट चैप्टर. सॉरी, फोर्स इक्वल टू मास इनटू एक्सेलरेशन. इफ वी से फोर्स इज अ वेक्टर, सो इज द फोर्स हैविंग अ डायरेक्शन? यस. तो उसके पेरेंट्स कौन कौन है? मास एंड एक्सेलरेशन. मास इज स्केलर, acceleration is vector. जो acceleration का direction है वही force का. That's why we say when a body is rotating in a circle, centripetal force अगर आ जाएगा then the centripetal force में centripetal acceleration, centripetal force keeps you towards the center, the centripetal acceleration also keeps you towards the center. ये हम 11 वगैरह में देखेंगे. So since there is no access, so as we go to the chapter, my job is now not to go as per the chapter, but let us focus on deeper points. So uniformly accelerated motion means there is uniform acceleration. Uniform acceleration तो कितने कितने बच्चे पैदा हो गए जरा देखें तो बहुत सारे बच्चे पैदा हो गए. एक U बच्चा पैदा हो गया, एक V बच्चा पैदा हो गया, एक T बच्चा पैदा हो गया, एक A बच्चा पैदा हो गया, बस. और ऐसा करते करते डेफिनेटली ये आपका जो डिस्प्लेसमेंट है इसको भी एक बच्चा बनाना पड़ेगा. डिस्प्लेसमेंट बच्चा का नाम कितना होता है? S. तो ये हो गया SUVAT. तो यहां से ये चैप्टर शुरू हो जाता है. ऑल द इक्वेशंस ऑफ सुवैट जो आप पढ़ने वाले हो, अभी आगे हम रिवाइज करेंगे. दे आर एप्लीकेबल ओनली व्हेन द कंडीशन इज uniformly accelerated motion in a straight line. If this criteria is not met, say suppose this car's acceleration is not constant. An aircraft taking off from runway doesn't go with constant acceleration. The acceleration is not constant. Then in that case, can SUVAT be applied? No. No, simply no. Only when acceleration is constant and the motion is in a straight line, then only. But in grade 9, all the problems that we are going to get will be of this scenario. In grade 10, we will have curved path. सर्कुलर पाथ में एक एक्सेलरेशन नहीं है ना, तब आपका सवाल होना चाहिए which acceleration you want to calculate. There will be an angular acceleration, there will be a tangential acceleration, there will be a centripetal acceleration. अब centripetal acceleration देखो पूछ ही दिया तो centripetal acceleration में हम, this is just out of course, we say that the centripetal force is equal, F is equal to mv square upon r. mv square means this is the mass, v is the tangential velocity, not angular velocity, r is the radius of rotation. यहां से acceleration कैसे निकालेगा पता है? फोर्स का डेफिनेशन क्या होता है? ऑलवेज मास इनटू एक्सेलरेशन. कंपेयर द टू इक्वेशन. Acceleration is equal to v square by r. This is grade 11 stuff. And this acceleration will be known as AC. Why it is known as AC? The reason it is known as AC, because this is coming, who is giving birth to it? The person giving birth to it is the centripetal force. Centripetal force आपको center की तरफ खींच के रखता है. Otherwise the body would have gone out of the orbit. So centripetal acceleration also acts this side. So छेड़ दिया तो और छेड़ दिया, अब कुछ नहीं कर सकते. So 1 minute. So this will be my tangential acceleration in grade 11 will be in this direction. Centripetal acceleration will be in this direction. Then you should again ask me a question. Sir, इतना acceleration अगर body को आ गया, then इतना acceleration अगर body को आ गया, तो finally what is the acceleration on the body? So two vectors. Again, we will be calculating what is known as the resultant of two vectors. Be ready for grade 11. This is the final acceleration that is acting on the body. And this acceleration will be written how? This acceleration will be written as A, which is the vector sum of AT plus AC. This is waiting for you in grade 11. ट्रायंगल करो या ट्रायंगल वो एक ही चीज में करते, बाकी और जगह पे हम लोग ऐसे ही जाएंगे. ट्रायंगल विल नॉट वर्क आउट. सो दिस इज व्हाट इज वेटिंग इन ग्रेड 11. अगर तब ये समझना है, अभी ये समझना है. ये क्लियर हुआ एक्सेलरेशन की कहानी? तो ये चैप्टर हमारा घूमते रहेगा इनके ऊपर. At here I will now again explain what is rest, what is motion, what is average velocity, average speed, all सब बात करेंगे. लेकिन ये कहानी समझ में आएगी नहीं? बोलो. बहुत अच्छी बात है, बहुत तेज बच्चे हैं आप लोग. चलिए चैप्टर शुरू होता है. द चैप्टर स्टार्ट्स विद डिस्कशन ऑन द कॉन्सेप्ट ऑफ, जैसे इसके ऊपर आपको बहुत सारे 1 मार्कर टाइप क्वेश्चन आ सकता है. द चैप्टर स्टार्ट्स डिस्कशन ऑन रेस्ट वर्सेस मोशन. ठीक है, कोई भी ऑब्जेक्ट को रेस्ट या मोशन दिखाने के लिए द थिंग दैट वी नीड इन आवर हैंड इज ऑलवेज, again, if you want to study in advanced manner, we say we need a frame of reference. Okay, you have to have a frame of reference, and in this frame of reference, if you see the position of the body, if the position of the body changes with respect to this frame of reference 0 0, if the position is changing, we say that the body is under motion. और इसको हम क्या बोलते हैं? फ्रेम ऑफ रेफरेंस, फ्रेम ऑफ रेफरेंस। ये फ्रेम ऑफ रेफरेंस किन चीजों की से बनता है? दो ही चीज चाहिए आपको, एक कोऑर्डिनेट सिस्टम आपको चाहिए, ठीक है, वन कोऑर्डिनेट सिस्टम यू वांट, एंड अनदर थिंग दैट यू वांट इज अ टाइम, टाइम क्लॉक। ये दो चीज है तो आपका फ्रेम ऑफ रेफरेंस तैयार हो गया। आप इस फ्रेम ऑफ रेफरेंस को कैसे देखते हो? ये फ्रेम ऑफ रेफरेंस को आप एक पेड़ को भी फ्रेम ऑफ रेफरेंस बना सकते हो। With respect to this tree is my frame of reference. If the position of the object is changing, then the object is in motion. If the object does not change, then we say what? The object is at rest. Or else you can also have a clock. इस frame of reference में एक clock भी होना चाहिए। Clock हो गया तो पूरा frame of reference है। Now question arises, they are not changing, but again you may have a third frame of, see it all frame of reference is dependent upon the viewer, ठीक है? आप ऐसे view कर रहे हो, मैं आपको यहाँ से view कर रहा हूँ, I am viewing this entire system, थोड़ा concept लगाने की सोचिए, मैं इस system को view कर रहा हूँ sitting at जुपिटर, मैं जुपिटर में बैठ के आपको देख रहा हूं, ये भी मूव कर रहा है। Why is it moving? Because इसका अर्थ ही मूव कर रहा है। So nobody is permanently at rest. Then we say, are they at rest? They are relative to one another. They are at rest. If this is their frame of motion, then they are at rest. Frame of reference, they are at rest. But for this frame of reference, you are not at rest. So it appears कौन किसको कैसे देख रहा है, समझ में आया ना? Clear हुआ? Rest and motion. Somebody may ask you that everything is permanently at motion. It's a true. There is nothing called rest. Rest is only something that you perceive. Are we fine? Clear? चलिए next topic में चलते हैं. Our next topic is a little bit of dip into the concept of scalar versus vector. हालांकि पहले ही बहुत ज्यादा बोल दिया, पर समझ लेते कोई बात नहीं. Scalar versus vector. तो physics में all the quantities that we study are classified under two categories. One category pertains to the scalar quantities, one category pertains to the vector. The scalar quantities can be fully and sufficiently expressed only by their magnitude. इन्हें मैग्नीट्यूड से ही पूरी तरह समझाया जा सकता है। जैसे अगर कोई टेम्परेचर की बात करे, व्हाट इज द टेम्परेचर ऑफ द बॉडी? द टेम्परेचर ऑफ द बॉडी इज say 346 Kelvin. We do not need to say what is the direction of it. What is the pressure? Pressure में भी direction नहीं होता है. Pressure is a scalar quantity. Now remember, pressure is force per unit area, but pressure is a scalar quantity. ठीक है? Electric current is a scalar quantity, not vector. Electric current लोग बोलेंगे no sir, but positive current next, because electric current does not add up as per the vector law. That direction that we are given is a conventional direction. Positive goes this way, negative. So electric current is also. So some of the quantities, let's say energy, जैसे temperature हो गया, energy हो गया. They might ask you, who among the following is not a scalar quantity? Energy. ये सब में आप confuse हो सकते हैं. Pressure हो गया, then electric current हो गया. Weight vector है बेटू. Weight is always a force. फिर इसमें mass हो गया. उस पर तो आएंगे जब gravity पढ़ेंगे, फिर उसमें आएंगे mass, then energy हो गया. And then work हो गया. Work and energy are okay. So work हो गया. So speed हो गया. Very good. Distance हो. Now these तो you know. See these two we will be covering in our particular time हो गया. Okay. Time is also. So these two will be anyway studying. If they give some other units, these other physical parameters, then these parameters are also. Then voltage हो गया.
Electric current to voltage, like,
No, electric current and voltage are two completely different things. Voltage is different, current is different. ये आप next year पढ़ेंगे. Okay, ये हो गया. Now there are some physical quantities where magnitude is not sufficient, so we need magnitude as well as we need direction. हमें direction भी specify करना पड़ता है तभी जाके. जैसे इन सब का बेस्ट एग्जाम्पल में आता है फोर्स. एक थप्पड़ मारो, किस तरफ मारो, कहां से मारो, किस गाल पे मारो, कितना घुमा के मारो. सो फोर्स आ गया. देन डिस्प्लेसमेंट, धीरे धीरे एक एक करके, ये तो हम पढ़ेंगे इस चैप्टर में. डिस्प्लेसमेंट हो गया. डिस्प्लेसमेंट पैदा करता है वेलोसिटी. वेलोसिटी पैदा करता है एक्सीलरेशन, एक्सीलरेशन और मास और वेलोसिटी से आगे जाके वी लर्न अबाउट समथिंग कॉल्ड मोमेंटम। जैसे आपने वर्क बोला तो वहां पे टॉर्क आता है। ऑल दीज आर वेक्टर क्वांटिटीज। A vector quantity needs both magnitude as well as direction in order to it to be specified. ठीक है? And हाँ impulse is a impulse is always change in momentum. Impulse is also a vector quantity. Impulse होता क्या है? Impulse is a force which acts for a very small period of time. So momentum is equal to what? Momentum is mass into velocity. And change in momentum, we say that is momentum over time is always giving you the force. Delta m gives you the force. So delta m ही होता है impulse, जो कि होता है force into time. Force which acts for a short period of time, that gives you the delta m तो नहीं बोलना चाहिए, I should have written it as p. So delta p. ठीक है? ये सब जब वो चैप्टर करेंगे तब करेंगे, इसको अभी छोड़ के रख दीजिए. Let's not eat our head on this. ठीक है? We are not, because at that question the magnitude part is what you are dealing with. But if you go to grade 11 and you are drawing say a graphical analysis of force, at that time direction will be necessary. जैसे हम वेक्टर्स के प्रॉब्लम करते हैं उस वक्त आपको प्रॉब्लम दे देगा 30 डिग्री पे है 40 डिग्री पे है तो आपको लिखना है find the resultant force. So that time you will say resultant force is 45 degree at 30 for, so resultant force is 45 Newton 30 degree with the horizontal और 10 डिग्री विद द वर्टिकल. आपको मेंशन करना पड़ेगा. हाँ बोलिए. Negative work means you have to read it like this: work done by the system, work done on the system. When you are working from the system's perspective, work done by the system is positive. Work done on the system is system कुछ नहीं कर रहा है, system के ऊपर का. So that's like spring. स्प्रिंग में अगर हम देखें लाइक से फॉर एग्जांपल ये क्वेश्चन को तो ऐसे ही आंसर कर सकते हैं. देखो सोचो, दिस इज अ स्प्रिंग, एग्रीड. नाउ यू पुल द स्प्रिंग दिस साइड, यू आर पुलिंग दिस फोर्स, दिस इज द applied force. Applied force is in which direction? This direction. Then the elongation, that is the delta x, will be seen in which direction? It is also in this direction, right? यहाँ पे अगर हम when we talk about the work done by this spring, you don't know the expressions right now. At the time work done by this applied force, it will be what? Force into displacement into cos of 0. The work is positive. Yes. Now change your perspective and see from the other side. Let's see from the other side. If you have pulled it this side, doesn't the spring want to contract? So the spring force is acting on this side, Fs, and displacement is on this side. So cos 180. So work done by the spring force is negative right now. Work done by the applied force is positive. Work done by the system, work done on the, therefore never say work done. Proper books in like good foreign books will always write work done by the system. देखो physics पढ़ना कभी खत्म ही नहीं होता है. Even when I read work now, again higher books, I still every day see अच्छा ये ऐसे था, ये ऐसे था, रोज नया कुछ सीखने को मिलता है. So there some books will say always try to narrate in this manner: work done upon the system, work done by the system. Work done by the spring is negative. Work done on the spring is positive, because spring को जब work करा रहे हो तब ये work done by the spring means मेरा बेटा क्या work कर रहा है, तो बेटे का force आएगा ना. Spring का force किस तरफ है? इस तरफ. Compression की तरफ देखो तो when you compress it, spring force is in which direction? Spring बाहर निकलना चाहता है. Spring force is in that direction. That's why you will always see work done by the spring is negative. Every case work done by the spring will be negative. Why? Because ulta ho raha hai, and work done on the spring will always be. But again, here there is one case. If you see this force is on this side, the other way you will see the force on this side. But whatever way is the force, we will see the force multiplied by the direction of the displacement. So even if you are compressing the spring, मान लो इसको compress करो, applied force in this direction, compression in this direction, work done on the spring positive, work done by the spring, spring wants to come out, so spring force is on this side and this force, so work done by the spring is always negative. Clear हो गया इतना सा भाई साहब? आगे बढ़े, ठीक है। अब आगे आते हैं नई चीज पे। यार बार बार पीला रंग काय को आ जाता है? रितांशु बोलो, अभी रितांशु बोलो ना, दीपांशु बोलो यार, पीला रंग क्यों आ जाता है? डिस्टेंस और उसकी सौतन, कौन? डिस्प्लेसमेंट। हमेशा इनमें लड़ाई होती है। तो ये सब आपको कभी सी योर द क्वेश्चन, द प्रॉब्लम विद योर इज दैट योर मार्क्स आर सो लेस in of physics that you don't know what will be asked and how much can someone ask, but still concept should be correct. What is distance? Distance is the actual length of path between two objects irrespective of direction of travel. So can you define the distance between 2 points? No sir, distance between 2 points can be in how many ways of distance, how many types of distance can be there between 2 points? Infinite types of distance can be there based on who wants to go which way, right? Very good. Displacement, shorter straight line path between 2 points तो नहीं बोलेंगे in physics, 2 points नहीं बोलते, initial and final point. So if this is my initial point, okay, initial point, and if this is my final point, then displacement is always the shortest straight line. Now here also you should be very perfect. It's not just like that. You should say what is the displacement from, now we'll get a little bit more serious. What is the displacement from A to B? A to B, that time A becomes my initial, B becomes my final. So my displacement from A to B will be given by whatever, say it is S in the direction from A to B. What is the displacement from, somebody asked me, say from B to A? In this case this becomes my initial and this becomes my final. So I say, so this is given by, this is a vector quantity. Now this is a vector quantity given by S, say B to A. I write it as, say I write it as SAB, and I write this vector as SBA. Okay, this is the displacement from the initial point B to A as measured from B towards A, the shortest straight line. Can you equate these two? Oh, why not, sir? SAB as a vector is negative of SBA as a vector. They're negative. However, the magnitude of SAB is equal to the magnitude of SBA. At grade 9 level, somehow you are more comfortable and your problems come like this: Delhi to Jaipur and Jaipur to Delhi. Delhi to Jaipur and Jaipur to Delhi, both displacement in magnitude may be 300 kilometers, but Delhi to Jaipur is 300 kilometers west, and Jaipur to Delhi will be 300 kilometers east. वेक्टर की परिभाषा से दोनों बराबर नहीं है, इक्वल एंड ऑपोजिट है, मैग्नीट्यूड इक्वल है, डायरेक्शन ऑपोजिट। क्लियर? कितना उंगली है? 5। सो रहे हो तुम लोग? ऑल स्लीपिंग? वेलकम टू द क्लब, द क्लब। ओके, अब नेक्स्ट मैचेस कब है क्रिकेट के, बताओ। क्या है ये? तुमने नहीं देखा है? 13 जनवरी के टाइम पे जब ये संक्रांति लोहड़ी होती है ना, तो लोग ये आग जलाते हैं घर में। तो मुझे तो बॉर्न ब्रॉट अप इन असम, तो हमारे उधर ठंड बहुत पड़ती है, आग फायर होता है, इट्स वेरी कोल्ड। बैसाखी, नॉट बैसाखी, संक्रांति। मेरी मम्मी को उनसे कभी मिलवाना बड़ा जरूरी है। मैंने उस संक्रांति जो फायर होता है ना, जिसको लगाते हैं लोग लोहड़ी में, पंजाबीज डू इट ऑन लोहड़ी वन नाइट बिफोर, बहुत लोग सुबह, मेरे उसमें बहुत कुछ चीज गए हैं, ग्लव्स, बॉल, बैट। मेरा भी तुम्हारी तरह था, घर में आने से मंजूर नहीं था। तो in our days, they were, my mother and all, they were not so efficient in, you know, cutting vegetables with knife and all, just like we do. So they used to have that फ्लोर में बैठ के ऐसे ऐसे सब्जी काटते हैं ना, ऐसा। इन दैट मेनी टाइम्स मैं टेनिस बॉल आलू की तरह 2 बार काट दिया है मेरी आंखों के सामने। तुम्हारा ये होना बहुत जरूरी है। एंड आई यूज्ड टू हैव वन स्मॉल मिल्क मेड का डब्बा, देखे हो ना, ऐसा। इसके अंदर बहुत ये सब रहता था। क्या? मारने की चीज नहीं। The place where I have been born brought up, we never used to get kites for purchasing, so we used to make kites. तो काइट बनाने के, Assam is very good in bamboo, so you get all types of bamboo, बीच में You want the what you call the joint to be in the middle so that the kite flies properly. So all these we used to use knife and shave those and make them and keep, so that whenever it is urgent just लगाओ. और उनको शेव कहाँ करते थे? You used to take the whole thing out here and you shave it here like this, like this, like this, and you shave it. So she used to take all of them together in front of my eyes and अभी वो किया बोल के आज ये हालत में डिस्प्लेसमेंट तुमको समझा पा रहा हूं. अगर वो नहीं करती ना तो ये वाला नहीं हो पाता. तब बहुत गुस्सा आता था. उन्होंने भी कुछ अरमान देखा था मेरे लिए, इसलिए हमने किया था, पर हम सुधर गए थे. आप उस चीज को देखो. Why that was done? We feel that, you know, why that? Like many times I tell my mother, had it been US, you have been prosecuted by the FBI. मुझे छड़ी से मारने के लिए, इससे मारने के लिए, उससे मारने के लिए. But that was very necessary. ये जो आज के बच्चे सीधे नहीं होते हैं ना. I'll tell you just one reason. Afternoon I had gone to Ratnadeep. So that time the TIP school was over. So two dads taking their children. The two children are classmates, and the two dads are not talking to each other. The children are going. Even the Ratnadeep fellows are not saying anything. They're just opening the ice cream, that coffin wala cabinet. Gadam, close. This way, close. That way. My hands are just itching to slap both of them. बच्चा बच्चे की तरह रहेगा, मैं डबल प्यार करूंगा. My wife is just saying, ignore, come, let's go to that. She knows, she has understood my irritation has started. But I could not stop. मैं गया, because I also had to buy ice cream. I said, just get lost from here. धीरे से. Is it not striking that dad कि उसका बेटा क्या कर रहा है? And if I say, he will be the number one to write on a Facebook out here. And if you go to the dad's childhood, na, you would see he had never participated in extempore debate. Oh, class में चुपचाप बैठा हुआ रहता था. That dad must have been a very timid profile. Frog जैसा रहा होगा class days में. लेकिन अभी क्या है? घर, गाड़ी, बंगला, पैसा सब आ गया. अभी सारा दिन ऐसे बैठ के फेसबुक. बाहर निकाल के टप बोले चुप हो जाए. क्या बच्चा बड़ा कर रहा है? I lost my. There cannot be chaos. You can't do chaos in a shop. You're not buying anything. And he takes a Kinder Joy, he eats it. His dad takes the 2 shells of the Kinder Joy and then goes to the counter to scan it. And if anyone says, बच्चा है ना, बच्चा है तो क्या हुआ? एक दिन एक झापड़ मार के देखी तो ऑटोमेटिक लाइन में आ गया. I am a very, very supporter. Thrashing is very necessary. One who has not been thrashed, वो ठीक ठाक हो ही नहीं. Unless it's been brought properly. Otherwise, thrashing is mandatory. बिना thrashing, और पेबल सिटी में तो mandatory thrashing. चलो आगे बढ़ते हैं. चलिए, तो क्या हो गया? डिस्टेंस डिस्प्लेसमेंट हो गया. अच्छा, अभी आते हैं नए क्वांटिटी पे. और क्वांटिटी का नाम है हमारा, बात करते हैं थोड़ी सी स्पीड भी. अच्छा, उससे पहले थोड़ा सा ये भी था, मोशन के बारे में बात में 2 चीज छूट गया था बेटा. मोशन में हम क्या बात करते हैं? यूनिफॉर्म, ओके, एंड नॉन यूनिफॉर्म. यूनिफॉर्म मोशन कब होता है? A body is said to be under uniform motion. First condition, travels in a straight line, covers equal distances in equal intervals time. Third is no matter how small. तीनों चीज लिख लीजिए. यूनिफॉर्म मोशन होने के लिए आपको 3 क्राइटेरिया होना जरूरी है. बॉडी स्ट्रेट लाइन में चलना चाहिए. नंबर 2, इक्वल डिस्टेंसेस. ओके, ये सी व्हाटएवर यू राइट इन तमिल, तेलुगु, बांग्ला, व्हाटएवर, ये 3 लाइन रहना चाहिए. इसको ब्लैक लाइन से लिख देना, टीचर को समझ आए. इक्वल डिस्टेंसेस इन इक्वल intervals of time. And the last one is very important because it will take out any ambiguity from there, and that is no matter how small the time intervals may be. I write every year, तो मेरे दिमाग में बैठ गया, जितना लिखोगे उतना सीखोगे. Maybe these 3 lines should be there, these 3 points. If these 3 points are not there, नंबर. इसको कहते हैं हम आंसर लिखते वक्त जो कहते हैं ना, मेंशनिंग द कीवर्ड्स. दीज आर कीवर्ड्स. इनफैक्ट आप पैराग्राफ आंसर मत लिखो, आप लिखो अ बॉडी इज सेड टू बी अंडर यूनिफॉर्म मोशन इफ Then look, see if I'm the teacher, how does it become important? How easy it becomes? If straight line तो मत लिखना, if it moves in a straight line, वाह वाह वाह, it covers equal distance, अति उत्तम, and no matter how small the time interval से, बस बच्चा 3 out of 3 in this question, no points to deduct. Crystal clear, voice crisp, or girl is crisp about her concept. इतना पैराग्राफ लिखने की जरूरत नहीं है, 3 चीज पूछा हमने, दादाजी का नाम पूछा है, तो 1942 की बातें बोल के क्या, दादाजी की बात, दादाजी का नाम है श्री श्री, वो या तो अभी जिंदा है या परलोक सुधार गए हैं, और मैं उनके बताए हुए कदमों में चलता हूं, उसकी भी जरूरत नहीं है, दादाजी का नाम पूछा है। आगे बढ़े, नॉन यूनिफॉर्म मोशन, तो इसी का उल्टा हो जाएगा, ए बॉडी इज सेड टू बी नॉन यूनिफॉर्म मोशन इफ इट डज नॉट ट्रेवल इक्वल डिस्टेंसेस इन इक्वल इंटरवल्स ऑफ टाइम। तब और नीचे की बात ही नहीं आती है, यही मैं फेल हो गया। हाँ बोलो बेटा।
body moves in a straight line and covers equal distances in unequal intervals of time, unequal in equal, and unequal distances in unequal intervals. So much equality, right?
अब कर लीजिए, अभी आपका क्या करेंगे आप। मैं होने से क्या लिखूंगा पता है, ए बॉडी इज सेड टू बी अंडर नॉन यूनिफॉर्म मोशन इफ इट डज नॉट ऑब्जर्व आइदर ऑफ द फॉलोइंग, does not travel in a straight line, moves in a straight line, covers equal intervals, equal distances in equal intervals of time, no matter how. 1 में अगर फेल हो गया 2 और 3 देखने की जरूरत ही नहीं है। 1 में कैसे फेल होगा, कर्व में जा रहा है, कर्व में जा रहा है तो सुवेट ही नहीं है, वेलोसिटी चेंज हो रहा है उसका, है ना, राइट। तो यूनिफॉर्म स्पीड एंड यूनिफॉर्म मोशन, नो डिफरेंस, rather uniform motion and uniform velocity, there won't be any difference. Uniform motion and uniform velocity, because in order to undergo uniform motion you have to have uniform velocity. और uniform velocity क्या होता है, speed in a defined direction, speed क्या होता है, distance travel per time. So say let us define uniform velocity. A body is said to be moving with uniform velocity if it moves in straight line, covers equal distances in equal intervals of time, no matter how small the time intervals are. So therefore, though we will discuss graphs in detail later on also, but यहाँ पे ऐसे ही पूछता है तो लिख ही लो, लिखने में कहा जाता है। अगर हम इसका xt ग्राफ प्लॉट करेंगे यूनिफॉर्म मोशन, so uniform motion's xt graph will always be straight line, हाँ straight line आएगा, ये हो गया आपका xt, या फिर आपके लैंग्वेज में st. Foreign books will write them as x at t and t. Now, x at t means displacement at a time t. X at t, because it makes sense when you go for 2-dimensional motion, then you will be writing your motions at what? 2 dimension में आप ऐसे लिखेंगे, x at t, this will be the x axis, and y at t, this will be the y axis. जैसे एक बॉडी मेसी का किक ऐसे जाता है, यहाँ पे बॉल कितना दूर गया सर, this much is the x at t of the ball. And what is this? This much is the y at t. The ball has traveled horizontal also, and the ball has traveled vertical also.
Yeah.
That's why x at t and y at t. And like we guys, the desi guys, we at that time learned it like this: sxt, syt. So it becomes more cumbersome. I would have also preferred to go by xt and yt, but why that is not given? Because many children will confuse in the graph. Sir, x-axis has gone here, x at t. This is not x-axis. This is displacement at time t. Our habit is to write x here, na. So xt ऐसे लिखने से बच्चा फिर घबरा जाता है. Like in Pebble kids, oh my child had trauma last night. How did they do the syllabus like this? ठीक है? So are we fine with uniform motion, non-uniform motion? And if you are having non-uniform motion, how does your graph look like? Well, that's always your option. You can give the graph like this, जैसा भी straight मत करना उसको, बस खत्म। समझ में आया? बहुत अच्छी बात है। अच्छा ये ग्राफ कैसा है? ये क्या बोलोगे, चम्मच वाला ग्राफ? Up till the time t, the body was in uniform motion. After that, the body is in non-uniform motion. ऐसे बहुत प्रॉब्लम होते हैं, थोड़ा देर यूनिफॉर्म मोशन में जाएंगे और उसके बाद नॉन यूनिफॉर्म, बिटवीन 2 टोल गेट्स आफ्टर अ सर्टेन पॉइंट यू आर ड्राइविंग एट क्रूज कंट्रोल, यूनिफॉर्म मोशन, उसके बाद भैंसा आ गया सामने, नॉन यूनिफॉर्म मोशन हो गया। ठीक है, चले आगे। ये भी कॉन्सेप्ट क्लियर हो गया। आज थोड़ा कॉन्सेप्ट क्लियर करते हैं। यूनिफॉर्म मोशन, नॉन यूनिफॉर्म मोशन हो गया। स्पीड, आइए स्पीड की बात करते हैं। स्पीड इज द रेशियो ऑफ डिस्टेंस ट्रेवल अपॉन टाइम टेकन। ठीक है, तो हमारी भाषा में डिस्टेंस ट्रेवल मतलब ये पूरा चैप्टर कैसे हो रहा है, स्ट्रेट लाइन में हो रहा है। तो ऑल इन आवर चैप्टर डिस्टेंस ट्रेवल मींस द डिस्टेंस बिटवीन 2 पॉइंट्स। सो आई वुड से एस फाइनल माइनस एस इनिशियल। अगेन हाउ डिड यू से सर एस फाइनल माइनस एस इनिशियल? वेल आई एम सीइंग इट फ्रॉम द फ्रेम ऑफ रेफरेंस ऑफ माय सी। अब नाउ अगेन ये ट्रायंगल लॉ चिल्ला रहा था ना, देखो ट्रायंगल लॉ काम में आएगा। नाउ दिस इज माय ओरिजिन, राइट? My body is here right now. This is initial. Initial का भी तो एक displacement है, कितना displacement है? S initial from the origin. And this is my what? S final. This is final point. These are vectors. So what is my displacement? My displacement is always from S final to initial. This is my displacement. So how do you write the displacement? Let this quantity, I don't know, let this quantity be something like R. So in vectors, we always say this vector and then this vector. I'm taking the because I have to follow this direction, right? I have to follow this direction. So I write S F vector plus my R vector or R vector. I'm just saying R. Just theoretically imagine karo. This is actually the displacement I am worried about. Is equal to this is hitting me in opposite direction. I should have come like this. I should have come like this. But this vector is pointing in this direction. Are you understanding? Grade 11 stuff, not grade 10. I am going like this. I'm going like this. Why did you go like this, sir? अरे भाई, I have to calculate final minus initial, तो ऐसे ही तो जाऊंगा। लेकिन यहाँ आते ही ये लॉरी तो उल्टा आ रहा है। Plus of minus should be equal to 0. Finally, vector sum ना, आप वहीं तो आ गए। ठीक है, तो अगर हम अभी R को करने की कोशिश करें, R को देखें तो R हमारा हो जाता है, if you take R then R becomes S final. नहीं, initial minus final नहीं, see it is initial, either you can go from this side, this is your 1 point, this is 2 point, that depends upon how you have taken the point. I have just taken if you go by this it will come as initial minus final, but we take it as final minus initial. उल्टा करके मैं कर रहा हूँ, so that's how we say, and this R is actually nothing but your delta S vector. So, हमारे कहने का मतलब है ये सब अभी आपका दिमाग में, अभी आपको दिमाग खराब करने की जरूरत नहीं है। आप ये याद रखिए that an average, when you go in higher classes you will understand, average of any quantity, whenever you calculate the average of any quantity, it is distance traveled, which is SF minus SI divided by the time. So the time was say TF minus say TI. This is nothing but delta S. This is nothing but delta T. Average is always difference by difference. ठीक है, difference upon difference. This is known as, this is speed, और ये जो निकाल रहे हैं ना हम, ये है average speed. So average speed के दो formulas होते हैं, total distance traveled by total time taken. And sometimes in grade 11 they will show you that between these 2 points what is the average speed, then we find it out this way. Difference. And delta means difference.
This difference is like always bigger quantity minus quantity.
हाँ, bigger quantity minus, हमारे यहाँ हमेशा final minus initial होगा, because we take final, because the concept is what is the displacement initial to final, so final minus initial. ठीक है, so but at R level how will we see? So have you understood the definition of speed? Speed is given as distance upon time. So what will be our SI unit? मीटर पर सेकेंड। इस स्पीड को हम दो जगह में पढ़ते हैं, वन इज एवरेज स्पीड एंड वन इज इंस्टेंटेनियस स्पीड। इंस्टेंटेनियस स्पीड, this is speed at a particular time. Average speed is also here, you don't get calculations on this. This is speed at a particular time, means if you say that the instantaneous speed of an object is 5 meter per second, then you should also specify what was the time.
So all in the air, find the speed at t.
At t, so you are actually finding at t equal to, means when your t has completed to 4 seconds, at the 4th second what is your t? Okay, now sometimes we say at a particular, like when you're getting ticketed by police due to overspeeding, the speed this is mentioned on the photograph has got a timestamp on it, that is instantaneous speed. After that you say sir हम तो घटा दिया, हमने जब फोटो खींचा तब तो आपका स्पीड ये था. So you are ticketed not on average speed, you are ticketed on instantaneous speed. Yes, Mulu.
An average speed, the formula given is taking both the speeds and dividing it by 2.
हाँ, नहीं, total speed divided by 2 we only do when acceleration is constant. That we can do, we can use that formula. That is not total speed. When we do for average velocity, when we do average velocity we say u plus v by 2. हाँ, नहीं, एक मिनट रुकिए. This don't confuse. This is average speed. Average speed is total distance traveled by total time taken. When you calculate average velocity at grade 9, you will be using a formula called u plus v by 2. U plus v by 2 works only when acceleration is constant. If acceleration is not constant, average velocity cannot work. Rather, to find average velocity, हाँ, तो no, total displacement निकालने के लिए भी आपको coordinate system में जाना पड़ेगा. Either you have to calculate that slope of the graph. That's where slope comes in. See, it's like this. In grade 11, the problem will come like this. A body is moving in a curve from this position to this position, okay? This position to this position, and the time is from here to here. अभी अगर आपको average निकालना है तो what will you do? This is the average, and this is the time. So it again becomes that this is displacement. जैसे आप देखेंगे ना, this point to this point, this is the displacement that you are worried about. Not like this. तब आप दो, but in that case, if acceleration is not constant, you can't use u plus v by 2. जो आप u plus v by 2 आप 9 में use करते हैं, क्योंकि 9 में chapter ही तो है ना, uniformly accelerated. So don't confuse. That is what you call the average velocity formula. This is average speed formula. In fact, the first equation of motion or the second equation of motion is derived by using that formula only. Average velocity is equal to initial plus final by 2.
For both of them, you can take the average of both the speeds.
That again, I'm saying you can. It is, if you are calculating velocity average or if you are doing the average of speed, how does it matter to you as long as you are एवरेज स्पीड करने से भी आप देखो, आप 10th में कोई भी प्रॉब्लम में डायरेक्शन के साथ आपको कोई लेना देना नहीं है इन ग्रेड 9. सो if you are calculating average velocity as u plus v by 2, the magnitude is also giving you average speed, but u plus v by 2 is not the right perspective of calculation. U plus v by 2 works only when you have constant acceleration, and that is you are doing from velocity to speed. Speed has a different formula. Total distance traveled by total time taken. अगर आपको speed का problem है तो आप, I will advise do by that formula only, because in grade 9 you won't get average velocity problem. You will get average speed, because speed का जो role है इस chapter में is limited to only what is speed, what is uniform speed. अच्छा, uniform speed का definition क्या है? There is the first criteria is not necessary. First criteria is not necessary. A body is said to be in uniform speed if it covers equal distances in equal intervals of time, no matter how small the time intervals may be. उसको straight line में चलवाने की कोई जरूरत नहीं है. यहाँ हम यूनिफॉर्म स्पीड की बात कर रहे हैं. यूनिफॉर्म मोशन नहीं, मैं यूनिफॉर्म स्पीड की बात कर रहा हूं. Please understand, don't get confused on one. We spoke about uniform motion, we spoke about uniform velocity, though we have not still now revised velocity. We spoke about the velocity part when we were discussing uniform motion. I'm saying if somebody tells me define uniform speed, speed के लिए डायरेक्शन तो कोई मायने ही नहीं रखता है ना. हाँ, होने दो, मुझे क्या लेना देना है. स्पीड्स का डायरेक्शन से कोई लेना देना. सर्कल क्यों, कैसे भी घूमो, हमें क्या लेना देना. And if it is a circle, that's why you see, right. Again, see one more interesting thing. When you study angular motion, like in translational motion, what do we say? what is the distance covered, what is the displacement covered. अगर आप angular motion में you will never see that people are talking about displacement, distance. Why? Because after a certain part you will again come to the starting point. A CD is moving, doesn't it come to the same point every time? So there we talk about this concept called revolutions per minute. How many revolutions? That does not mean that you are not moving, you're moving.
Distance.
So the distance does not make a roll out there. There we are more interested in revolutions per minute. Look how your speed is set in your car. 120 kilometers per hour. मतलब क्या ये गाड़ी एक घंटा में straight 120 kilometers cover करता है. Look how the speed of a drill machine is. 1000 RPM. It does not tell you, the drill machine speed is never specified as 200 kilometers per hour. कोई मतलब नहीं है. The drill, because it's a rotational motion ना, it will again come back to the same point. तो उसको translational में देखने से तो displacement is zero after every time. So what makes sense is revolutions per minute. This gives you an idea how speed the body is moving, or how fast the body is turning. Let's say we want a faster drill machine. Sir, 500 RPM लेंगे या 1000 RPM लेंगे? Obviously 1000 RPM faster है. 1000 revolutions per minute. ड्रिल मशीन के केस में कितना लंबाई जाता है हमें कोई मतलब नहीं है. So that is when you understand translation. So when you are working problems on speed, please calculate average speed as this manner. Rare of the rare you will get average velocity. Then average velocity, whenever acceleration is constant, we calculate u plus v. Somebody asked me define uniform speed. Then I would say a body is said to be uniform speed if it covers equal distances in equal intervals of time, no matter how small the time. I am not hell-bent upon to say that it travels in a straight line. That does not mean that a body which travels in a straight line is not having uniform speed. That means every body which has having uniform velocity has uniform speed, but every body which has uniform speed does not have. And the best example is the electron in the Rutherford's model. They are all having uniform speed, but they don't have uniform velocity, because their directions are changing every time. एंगुलर मोमेंटम तो आपका एंगुलर वेलोसिटी पढ़ने से भी और आगे की चीज है. क्यों चाहिए आपको? वो आप अभी समझ भी नहीं पाएंगे. हाँ,
Uniform circular motion is actually non-uniform motion.
यूनिफॉर्म सर्कुलर मोशन
It's non-uniform.
is an accelerated motion.
That is why it's not.
It's a non-uniform motion. Uniform circular motion means the translation, the tangential velocity part is uniform. Those v's are uniform. 1000 RPM, the speed part is uniform, but not the velocity. So it is an accelerated motion. Rather ये नहीं बोलते हैं कोई कि uniform circular motion is non-uniform motion. वो correct है. Better word is uniform circular motion is a accelerated motion. Otherwise, every uniform motion is non-accelerated. You are covering equal distances in equal intervals of time. Where is the question of acceleration? That's why in car you are pressing cruise.
I've never seen a cruise button. Where is it?
Steering. You come any day, tell me if I'll bring my car and I'll show you my car. We'll ride together and we'll do cruise and see. After cruise, you can take out your legs away. Any limit you can set. After, but only the speed should be more than 40. 40 के नीचे cruise नहीं लगा सकते. But every time you press the brake, like you're going in a cruise car, you have set it. Cruise means whenever, suppose you're at 70, if you press cruise, it will start cruising at 70. Then you can increase it, decrease it. But suppose there's a car in front of you and you brake it, the cruise immediately goes away. Again, you have to engage it. Yeah. So cruise you can set. It will be at, but all cars don't have it. Every car will not have. Manual transmission में cruise नहीं होता है.
Manual. Yeah.
हाँ. Manuals will not have. Only the automatics one will have cruise control. And if cruise you give, then cruise is good. Like you can drive on economy mode. You can set a speed. But the thing is that आराम से जाते रहता है. Sometimes it is bad also because you tend to sleep. You have nothing to do. Your legs are all silent unless and until you have to brake. But now if you have got cars with ADAS, adaptive cruise control system, so watching him in front of me, the car automatically slows down. ठीक है? तो अगले क्लास में अभी और थोड़ा ज्ञान बाकी है. We'll take 2 classes of ज्ञान, minimum 2 classes of ज्ञान. Let motion first be complete at least. Okay.